right, last section of chapter 11 is talking about Hero's and Brahmagupta's formulas for figuring out the area of two very specific shapes. So the first thing we have to remind ourselves is, what is a cyclic quadrilateral? A cyclic quadrilateral is just a quadrilateral that can be inscribed in a circle. So that means that these four vertices have to lie on the circle. Okay? Not every quadrilateral is going to be cyclic. So if you do have a cyclic quadrilateral, then you get to use Brahmagupta's formula to figure out the area of it. You would need to know all four lengths of the sides of your quadrilateral, and you would have to plug it into this big thing where you take the square root of the semi-perimeter, which is half of the perimeter, minus side length A, times the semi-perimeter minus B, times the side, or the semi-perimeter minus C, times the semi-perimeter minus D. Okay, that was a mouthful, sorry. So it's best to just do an example, right? So here's a cyclic quadrilateral where we have side lengths of 4, 5, 9, and 6. So the very first thing that you want to do is to actually calculate the semi-perimeter. So you just add up all four sides and divide by 2. So we got 12 as our semi-perimeter. So now we plug this into our formula, taking 12 minus each of the four sides and multiplying those four numbers together. So this becomes the square root of 8 times 7 times 3 times 6. Now, probably you're going to be asked to leave this in simplified radical form. And when you multiply all these together, you're going to get kind of a large number. So what might be easier is to, while it's in its kind of semi-factored state here, pull out perfect squares that you can see. So for example, if I took 8 and 3 and 6 and multiplied those together, I get 144. And that's a perfect square. So I can actually write this as 144 times 7 and then pull this out as 12 root 7. Okay? Now, here's something to think about. If you were to squeeze this point and that point together to become the same point, this side disappears and we end up getting a triangle, right? So this would go all the way to right there. And this side length goes away. That's me scribbling that out. And it would turn into 0. So if you still use Brahmagupta's formula, your four sides, well, one of the sides is 0. So using your formula, you'd have S minus 0, then S minus A, S minus B, and S minus C all multiplied together. Well, when you do that, you're actually getting Hero's formula. Sometimes it's called Heron's formula. So Hero's formula is for a triangle, and it'll work for any triangle. Whereas the cyclic quadrilateral was for the Brahmagupta's formula, you had to be cyclic. An area of the triangle, the Hero's formula, will work for any triangle. So you can see this right here. Here's the S minus 0, and then S minus A, S minus B, and S minus C. Okay, so let's see how that would look as an example. I'm actually going to make it kind of difficult for you. Because here, embedded in the problem, it's actually asking you to find the height of the triangle. So we're going to use Hero's formula to figure out the area. And then once we have the area, we can set that equal to the 1/2 base times height and then solve for h, because we know the base is 7. Okay, so let's do it. First things first is to figure out your semi-perimeter. And unfortunately, semi-perimeter, it's a fraction. So that's because we got an odd number up there, huh? Well, sometimes that happens, so we got to deal with it. All right, so now we're going to take the semi-perimeter, multiply by the semi-perimeter minus 4 times the semi-perimeter minus 6 times the semi-perimeter minus 7. Now, we're not going to convert these into decimals. We're going to leave this as fractions. So that means to combine our fractions, we need to rewrite 4, 6, and 7 with a denominator of 2. Then we can subtract. Okay, and then we can look and see here that 9 is a perfect square, but nothing else that we would multiply together would make a perfect square. All of these down here, when you multiply those together, that's going to be a perfect square. So this simplifies to 3 root 255 over 4. So there's your area. But now what we're going to do is we're going to take our area and we're going to set it equal to 1/2 base times height. 7 times 8. Okay? We're solving for h. So that means this 7 over 2 needs to get put over on this side as 2 over 7. And then we can simplify the 2 and the 4, and we get 3 root 255 over 14. So there's your height. Yeah, it looks really messy, I know. But it's fine, it's the answer. Okay. Congratulations, you guys made it to yet another end of a chapter. Congratulations.